2 years ago, I put together a video that described what I did on Temptress, my sailboat, by connecting lithium batteries and my lead batteries together. There's a lot of caveats, there's a lot of things, it's all in that video. If you do it wrong, bad things will happen. If you do it right, it's pretty good. Well, I've learned a lot more since then. I've learned not only a way to do it so that it doesn't require you to think about anything, but it actually makes life better for both of the batteries, better than being alone even. It's done with this. This is called a BankManager. It's a little device I've created. They're for sale now, and this video is how to use one of these to hook different kinds of batteries together. So, you've got an off-grid system. You've got batteries. Those batteries could be lead, they could be lithium. Generally, that's what they're going to be. Technically, they could be NiCad, but you know, nobody's doing that. Likely, you've got lead batteries, and if you've had this system for a while, you've found out that probably your most expensive part of the system is every X number of years, your batteries stop performing. You have to throw them out, buy new batteries, and then you've got a good system again. Lead, when used heavily, doesn't last a huge long time. Lithium is really cool. It's different. It has a longer life cycle. I think the number for lead, if you're lucky and you use it right, is like 400 cycles. Lithium iron phosphate should be like 4,000 cycles. Used to be, and I mean used to be, like last year, crazy expensive, but the prices come way, 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 way down on lithium. So it might be the time to switch. It might be time to bring some lithium into your system. The problem with bringing your lithium into your lead-based system that you already have is the lead has to be charged in a certain way. And you have probably all kinds of different charge controllers. You have one for your solar, you might have an engine with an alternator, you have all these different ways to charge. Wind, all kinds of things. You will have to change all those charge controllers if they're not brand new to charge lithium correctly. And I argue that even the newest charge controllers don't charge lithium really correctly. There's something called low current overcharge, and I haven't found one yet that isn't prone to that. It's probably the biggest killer of lithium iron phosphate out there, and we'll go into that in this video. So if you want to change from lead to lithium, realize there's a big expense of that hidden cost of changing out your charge controllers. And on top of that, the charge controllers that are currently available might not be doing the best job possible. Another situation is you could have a lithium-based system. You say, hey, I got lithium, I got the newest thing, that's great. It isn't necessarily. There's things that lead actually does better than lithium. Lead is really good with big pulses of power. I wouldn't try to start a vehicle with a lithium unless I had a massive, huge lithium. Lead, a little tiny thing, could start your big V8 engine. Think about your car. There's other issues. Lithium has electronics inside. It's fairly sensitive. If things go wrong, it can go south real fast and not recover. Lead's basically a big old cup of sulfuric acid and lead plates. It's really simple in there. If your boat gets hit by lightning, expect this to work. Don't expect this to work. So having some lead with you means you can start the engine, you can run your appliances, or at least your navigation equipment, and possibly your refrigeration. You can keep life going. If you just have lithium and you're well out, you're in the Stone Age all of a sudden. So I would argue the best system possible has some lead and some lithium. And I've developed this device called the BankManager that lets you hook these different chemistries together in a way that makes sense and lets you have the advantage of both. Let's look at how you hook one of these things up. I'm going to explain this from the point of view of someone that already has a lead system installed and they're just adding a lithium battery. I mean, very seriously, just bought a lithium battery and a BankManager and want to put the thing together. Here's what you do, and really, it couldn't be simpler. You already have a line coming from the negative of your lead batteries that goes to some distribution. You can run a wire from the negative of your lithium battery right to that same distribution or directly to the lead battery, whichever makes sense. But in short, you take the negative from the lithium and connect it right to the negative of the lead. After that, run a wire from the positive side of your lead system, that can either be the distribution bus or the battery itself, to the lead side of your contactor. Take the other side of your contactor and run that, well, through this current sensor and to your lithium battery. So essentially, you've connected your lead and your lithium in parallel, except that you've put my contactor in between on the positive side. When you initially install that and you follow the manual, this will be off, the batteries will be separate, everything will be safe to hook up, but just as a warning, there's a lot of power in these things. Whenever you make a connection, just touch it first. If you see a spark, make sure you didn't do something wrong. So here's what makes up a BankManager. There's three main components. There's a contactor. It doesn't have to be this contactor. This is one that we sell because I like this contactor a lot. But you can use any contactor you find around that works for you. You might have a huge system. If this was based on some municipal power plant, you would need a contactor that's bigger than me, and we don't supply that. The rest of the equipment can work with it, though. You might not want to pay the $150 we charge for this one. It's a really nice one, and it's well worth it. When you shop around, you'll see. But you can use a relay, and if you have a small system that's only going to pass, 20, 50 amps, you might be well served with a regular relay. It's up to you. But what a contactor does is it makes a connection between the two battery banks and can break the connection. You might think, why didn't I use transistors? Why didn't I do it in a solid state way? Well, I started that way. It's actually better to do it with a mechanical contactor. It's more durable and it's more reliable. So in short, this is the switch that brings the lithium into the rest of your system for charging or discharging, or can segregate the lithium away and separate it from all the rest of the system. Next thing I'll talk about is this. This is a current sensor. You may be more familiar with shunt type current sensors. A shunt current sensor is a known resistance, and you run your entire power supply through it. It works by having a drop in voltage that's proportional to the amount of amps, so the system can tell what's going on. But there is a drop in voltage, and not just from the shunt, but also from the terminals if you had to put on and all of that. It's just the engineer in me. I hate voltage drop. I've been living on 12 volts for 30 some years now. Any voltage drop is your absolute enemy, and I didn't want to put a voltage drop into this. So I did it a different way. This is a Hall effect sensor, and when current goes through a wire, it creates a magnetic field, and this thing can pick up on the magnetic field. It's very similar to like this amp meter, where you clip it onto around the wire. If you've used one of these, you've used one of those. So in short, this sensor can really carefully tell and very accurately tell the amount of current that's going in and out of the lithium side of your battery bank system. Finally, we've got the BankManager itself. Now, I know this looks like a rat's nest, and it wouldn't look that bad if you installed it properly, but I just put it together on the table. There's 8 wires and hooking it up, and all 8 wires, you notice, go from here to here. They go to different places on these devices, but really it's just one group of wires to hook up. This is the brains of the system. It has a display that tells you either the voltage of your lead and your lithium if they're disconnected, or if they're connected together, well, the voltage would be the same. It will tell you the voltage of your lithium system and the current that is either flowing in or out of it. That's pretty handy. It will tell you the percent of charge that the lithium is currently at, and a little graph for that at the bottom, and a couple little bits of information that tell you whether the contactor is connected or not. There's actually a blue LED light right behind this little insignia, and if I wasn't out in the blazing sun, this guy's connected right now. He's got kind of a blue glow, this guy. So that's another little clue about what's going on. You've got a little knob here, and if you push the knob, it will immediately disconnect the contactor. So it's kind of like a panic switch, but also it puts you into menu mode. And in menu mode, you can set up all the menu items, and then you can go back into normal mode and it'll reconnect. It's a lot of menu items, but for most people, there's only one menu item that you need to set, and that is, how big is this battery? So I've told this guy this is a 200 amp hour battery, and then just turned it on. I didn't set anything else. But there's a lot that can be set. It's all in the manual. If you go to the web page down in the description below, you'll find a link to the cell sheet, and the cell sheet has the manual for your perusal right now. Being an engineer, I would never buy anything that I don't get to read the manual first. So what does it do? How does it work? Starts out, these two batteries are disconnected. They could be at very different voltages. If you go back to that 2-year-old video, you'll hear me really harp on the don't connect them if they're at different voltages thing, because you can get a really tremendous surge of power with one battery trying to charge the other battery. So this device, above and beyond all things, won't connect these batteries until their voltages come together within a very narrow boundary. That happens naturally. If you just turn this thing on, let's say in the morning, and let's say your lithium is fully charged because you just put it in, when a charge starts to happen, coming in from solar panels, and this example, when the sun comes up, it'll start charging the lead battery and its voltage will start climbing up. When it climbs up into the 13.2 realm or whatever, and it becomes the same voltage as the lithium, this will bring the systems together. Now the lithium and the lead will just be connected. It's safe because they're at the same voltage, so no current. And the power coming into the system will go into the lithium. It goes into the lithium first because just the chemistry of it, nothing magical here. Lithium has a lower internal resistance than lead, so it will take power before lead will take power. But they're both taking some power. Generally, the lithium will get fully charged first, and it's beautiful how lithium charges. If you've had a lead system, you realize that if you're at 50%, it takes power like mad. But when you get above 80%, its voltage starts going way up, and the charge controllers have to throttle back. And it's bright sunny out there, I should be getting 40 amps from my solar, and you're only getting 20 amps from your solar. Then you're only getting 10 amps from your solar. Lithium, you get mostly all of what you give them right into them as a charge, right until the end. And that makes your solar panel array bigger. You actually get more out of your solar in a day because having lithium around. Anyway, eventually the lithium will get fully charged. Fully charged is really defined by you, but this device, following your instructions, will disconnect the lithium when it's fully charged. That is probably the single most important reason to get one of these. Fully charged, by the definition of the charge controllers that are out there that say they're for lithium, is charging to a voltage. You pick the voltage, and then comes the question, what voltage do you pick? Well, if you go back to the white papers and you read what the scientists that developed these do, or if you look at the battery manufacturer, they'll say charge to this voltage at this current. The current is absolutely critical. If you charge at a lower current to that voltage, you have overcharged and permanently damaged this battery. Won't die tomorrow, but it will have a cumulative problem. This device is able to dynamically change that target voltage. It's not exactly how it works, but there's a 3-dimensional math that took me quite some time to figure out, where I give this guy the voltage, the current, and a certain time constraint. And those 3 dimensions are used to decide when this guy is charged. Now, you can charge this either to 100%, which is where I personally set it because I've learned to trust this device, or you can set it to any other number on down to 50%. So once this has reached whatever you've set it for, it will stop the charge cycle. It does what lithium needs to do. Lithium can't be floated. Any voltage that it's held at over, for a 12-volt system, 13.48 volts, will do damage. So what do? Well, if you just disconnect this, yeah, sure, you could kind of run off your solar panels right to your devices, but if you turn on a microwave oven, well, that's bad. You're not going to have any power. You'd have to slam this right on really quick. There's just no way to do that safely. What we do here is we never disconnect the lead. So the lead is always available. You turn that microwave oven on. If it's small lead, the voltage will come down pretty darn fast. This will really realize that, lock them together pretty darn fast, and then you're running the microwave off the lithium. The big point is you can't float lithium up high safely. So this will leave the lithium off until it's appropriate. When the voltage comes down at the end of the charge day, either because the lead is fully charged, according to the charge controllers, or because the sun just went away and the lead hopefully will get charged up all the way tomorrow, the lithium comes naturally in. Now they're connected and you're in your night mode. The night mode, most of your power is coming out of the lithium. Very little comes out of the lead unless you turn on a big load that's too much for the lithium to handle. If you do, and in our case, that's our microwave oven, our relatively small lithium battery bank goes down in voltage, gets down into the realm of where lead can give power, and the lead just says, hey, I'll hold that beer, and takes care of things. As soon as the microwave is off, the popcorn's done popping, it goes right back to the other. And we've taken a surprisingly small amount of power out of the lead, but it was there for us. You'll run all night, mostly off lithium. The lithium will, beyond running your whole system, will actually use a tiny bit of power to hold your lead up to 13.2 volts, more or less. That is like being in a hammock on vacation for lead. That's what those little float chargers you put on your sports car when you're not going to drive it all winter, that's what they do. Hold that lead just up. So you should get a really long life out of your lead in this approach. Time goes on and the capacity of this starts getting used up. You can set a number to be the minimum amount of power you want to stop discharging your lithium at. So you can say, I would like you to stop using lithium when I get to 20% of charge. I'd like to leave that last 20%, or 15, or 18, or whatever number you want. And he'll disconnect the lithium. Now you're a lead boat. Of course, if the lead also goes dead, you know, it's not magic. Then you have no power, but that's how it is. On throughout till the next day. Of course, the next day, usually we're on solar, but maybe you start a generator. Power comes into the system. Everything goes back to where it was and repeats the cycle. As I said earlier, I leave Temptress, in fact, she's in the DR, unattended, set at 100%. Why I trust the 100% is because we did this test. We let this guy charge a lithium ion pack. We actually did it on a couple different boats for different lithium iron phosphate packs. And we let it go to 100% and then shut down. Then we immediately came and just forced this manually into a connection and watched very carefully on the battery voltage. Well, what had happened before it shut down is the voltage was going up, but not very, very fast. And then click, it went off. As soon as we would reconnect, within a tenth of an amp hour of power going in, the voltage started skying right up. That means we caught it just before that thing they call the hockey stick that lithium does, where it's starting to get itself into trouble. I trust that, so that's what I've done. If you didn't trust that so much, you can crank that down, 95, whatever you want. If you're going to leave your boat for a long time unattended, and maybe I should have done this with Temptress because it's not doing anything there. The manufacturers say charge these to 50%, discharge them if necessary to get them to 50%, store them at 50% charge, and come back every 3 whatever months and charge them back to 50%. Well, tell this guy that full charge is 50%, and if you leave your solar panels up, he'll do exactly that. He'll let them come down to 50%, won't put any power in them whatsoever until you hit that point. Then, you know, if there's some small activity, maybe you've left an anchor light running, maybe you've got a bilge pump that comes on occasionally. When they've come down from the 50%, they charge again. We've released the BankManager last year, actually about this time last year, I think. And since then, we've sold 100 of them with virtually no marketing except me talking about them on the channel. We've had really good luck. I have one complaint from a guy that I don't think could be happy, and I gladly gave him his money back. I've got 2 guys that found a bug, a legitimate bug. It's fixed in the latest software, but it only affected 2 of the 100 boats. It had to do with them having a very large load and a very small lead battery, more than we had tested on, but that's taken care of. Generally, I think this is now a success. So I'm confident about this product, pretty darn excited about it, especially with the new box. I hope it interests you. If you're interested in this, go down in the description below. There's links to all kinds of good stuff. There's a link to the manual, how it works. There's links to a Facebook group that you can ask and answer questions, not just from me, other people that own them. There is a Patreon section. And if you support us at the Dream Believers section in Patreon, you get my phone number. So what people are using that for is saying like, Clark, I want to redesign the whole electrical system. And we go through it all step by step. You can use that for mostly anything you'd like, but if you want to know if this would work for you and your boat, we'll go over it. I've told people no. But honestly, when you have lithium, it's just the right answer. I don't think the state of the art of charging these beasts is correct yet. I think this is the right way to charge them. If you want one of these and you don't live in the United States, you've seen in the past, we only ship to US address, we give away to do a courier service and all of that. If that's been too much hassle for you and you're in the EU, we now have a representative in the EU. He has stock in hand. So if you want to place an order, it's possible now to get that VAT prepaid mailed to you directly within Europe. If you're in other countries, we're working on methods, but it's not easy to take the US Post Office or US UPS from the United States and get insured mail to anywhere in the world. It costs more than the device. It's just stupid. I really appreciate all you guys that have bought one of these things and gotten back to me about, how they worked for you. We've got some little videos people have done and some little testimonials. They always just lighten our life completely. We got to get them up so that everybody can see them. But if this has worked for you and you can do a little video telling others how it worked for you, that would help. There are literally 100 people in the world that know how good this is, and it's a big world. If you buy one, you're early adopter of a new technology. That could be scary, but it also could be way cool. What's better than sitting on a bar stool explaining to all your buddies how you've got the best electrical system? Anyway, thanks for watching the video and see you next time.